Question number 19 of the worksheet on forces in motion. Particle P and Q are moving in a straight line on a rough horizontal plane. The frictional forces are the only forces acting on the particles. Find the deceleration of each of the particles given that the coefficient of friction between P and the plane is 0.2 and between Q and the plane is 0.25. Okay, so there's a plane, there's a particle P moving on it. They're saying that the only force acting on these two particles is the frictional force. So if it's moving in this direction, and let's say this is also moving in this direction, so then there's no forward force. Forward force is zero. Backward force is the friction, and we know that friction equals mu times R. So this is the backward force mu R, and this is the backward force for Q, mu R. Mu is given for both the particles. For the first one, it's 0.2. So this would be 0.2 R. And this would be 0.25 R. Okay. You have to find the deceleration of both the particles. So forward force minus backward force equals mass times acceleration. And here also forward force minus backward force equals mass times acceleration. Okay, now we need R. R is the force opposite to the weight. Weight is mg, which is 10m. And here also the weight is 10m. And R is opposite to that. So now we're going to replace R with, achha, I made a mistake. This is not R. This is friction for, acha, mu R ही थी, sorry, my bad. Mu R. Okay, so this is R upwards. So let's replace R with 10m in both the cases. So this would be minus 0.2 times 10m equals ma. And this is going to be minus 0.25. 10m equals ma. M and M gets cancelled. Acceleration equals minus 2 meters per second square. And here acceleration equals minus 2.5 meters per second square. So decelerating. The question has asked for acceleration or deceleration. It has asked for deceleration. Then for deceleration, you're going to write 2 meters per second square. And deceleration here is going to be 2.5 meters per second square. Okay, part 1 is done. At a certain instant, P and Q pass through the point A. Sorry, at a certain instant, P passes through the point A and Q passes through the point B. The distance AB is 5 meters. Okay. The velocities of P and Q are at A and B are 8 meters per second and 3 meters per second respectively, both in the direction AB. All right. So they're saying that at a certain instant, the particle P passes through the point A. This is A, this is particle P. And Q passes through B. So this is particle Q passing through B. And their speeds are 8 meters per second and 3 meters per second. And the distance between these 2 points is 5 meters. And both are moving in the direction of AB. That means both are moving forward in this direction. Okay. Find the speed of P and Q immediately before they collide. Okay. So find the speed of both the particles right before they collide. All right. So in this case, what you have to do is you have to form an equation of the gap between the two particles, because when they collide, when P and Q collide, the gap between particles is equals to 0, right? This gap is initially 5, but it changes with time and eventually the gap becomes 0. So you have to form an equation in which gap is equals to 0. Okay. Now, how do we form an equation for the gap? Let me draw the equation again. Let me draw the diagram again. There's A, there's B, and the initial distance or the initial gap is 5 meters. Okay. Distance covered by A would be this at time t. Sorry, this is P. Distance covered by particle P is going to be SP. Distance covered by particle Q is going to be SQ. And now the gap would be this. At any time t, this would be the gap. Okay. Now we need to form an equation of all of these. Gap, distance covered by P, distance covered by Q, and 5 meters. So notice that if we add 5 meters, this and SQ, so gap plus SQ equals this plus this. The distance is the same. If you add the blue lengths, that should be equals to the sum of the pink lengths. So 5, a gap plus, sorry, it should be 5 plus SQ, not gap plus SQ. So 5 plus SQ equals SP plus gap. So gap equals SP minus SQ plus 5. Just give me a second. अच्छा इक्वेशन मैंने गलत बनाई है. This is correct, but when you make gap the subject, SP should go to the other side and get subtracted. ये मैंने गलत कर दिया. So it should be SQ minus SP plus 5. Yes, now it's correct. So the equation for the gap between the two particles at any time t will be equals to the distance covered by Q minus distance covered by P plus the initial gap 5. Okay, so let's form an equation for SQ and SP. Okay, let's talk about SQ first. For SQ, we know the U, which is 3. U is 3. And we know the deceleration, that was 2.5. So A is equals to be negative 2.5. And time is t. So we can use ut plus half at square. So it's going to be 3t plus half minus 2.5 t square, which gives us 3t minus 1.25 t square. Okay. So we got SP. Now we're going to find SQ. Sorry, now we're going to find SP. SP, for SP, what do we know? We know that U is 8. We know the deceleration is 2, that is acceleration is minus 2, and time is t. So we're going to use SP equals UT plus half a t square. So it's going to be 8t minus t square. Substitute the values. Gap would be equals to SQ, which is 3t minus 1.25 t square, minus SP, which is 8t minus t square plus 5. So it's going to be 3t minus 1.25 t square minus 8t plus t square plus 5, and equate the gap to 0, because when the particles collide, the gap between them should be equals to 0. So it's going to be negative 0.25 t square plus बल्कि minus 4t, 8 minus 8 and plus 3t, so minus 5t.
मैम 0.75 टी स्क्वायर नहीं होगा पॉजिटिव
0.75 कहाँ से आया?
ओह अच्छा मुझे लगा 2 टी स्क्वायर सॉरी
Okay. So ये quadratic equation बन गई है. Let's slightly simplify it and then solve it. So this, you can multiply both sides with 4, or you can just solve it from here. So I'm getting t square minus 20t minus t square minus 20t plus 20 equals to 0. बल्कि minus 4 से multiply कर देना चाहिए था. So then the signs will change. Plus, plus, and minus. Solve this quadratic equation using quadratic formula or middle term breaking if it's possible. I don't think middle term breaking is possible. So we use quadratic formula minus b, t equals minus b plus minus square root b square minus 4ac over 2a, which gives these two as
मैम
answer.
एक आंसर आ रहा है 0.954
ठीक है.
और मैम दूसरा है नेगेटिव 20.954
ठीक है. So time negative तो हो नहीं सकता. So only use this. So when the particles are about to collide, that is when the gap is equals to 0. So time is this. अब पूछा क्या था इस क्वेश्चन में? पूछा था कि find the speeds of P and Q immediately before they collide. So we have to find V of both the particles. Time हमें पता चल गया है, U हमें पहले ही पता था और acceleration दोनों की पहले ही पता थी. So V निकल आएगा. Okay, so for P, particle P or particle Q. For P, U was 8. Acceleration was -2. Now time is 0.9544 और आपने V find करना है. So we can do V is equals to U plus AT. So V equals 8 minus 2 times 0.9544, which gives 6.09 meters per second. This is the answer we get for P. Similarly for Q, U is 3 A is negative 2.5 and time is the same 0.9544. Use the same equation of motion. V is equals to U plus AT. 3 minus 2.5, 0.9544, which gives 0.614. Yeah, answers. Let me know when you're done noting it down. हुआ नहीं अभी तक?
Done.
Okay. अजहर कर लिया ये?
यस मैम।
ओके अच्छा, इस क्वेश्चन में हमने क्या चीज सीखी है जो हमने पहले ही नहीं की हुई? हमने ये सीखा है कि इफ देयर इज अ पार्टिकल, लेट्स से व्हाटएवर p कर देते हैं, और एक पार्टिकल q है, they're both moving in this direction and there's an initial gap given which was 5 meters or whatever. Okay, so you have to find the velocities of both the particles or speed of both the particles when they collide. So when they collide, the gap is equals to 0. So you have to form an equation that satisfies this. Gap between the two must be equals to 0. So you form an equation in terms of t and get a t from here, and then use that t in the equations of motion later. How do you equate the gap to 0? You write the expression for the distance of the particle ahead, which is SQ. Then you subtract the distance of the particle that is behind, SP, and then you add the initial gap between the two, which is plus 5, and equate it to 0. So if you don't want to derive this equation like I did in the question, just remember this, that gap is the particle ahead's distance minus the particle behind distance plus the initial gap, if both the particles are moving in the same direction, like they were both going right in this question. If the particles are moving towards each other, then obviously the theory changes. Okay, that was question 19. Question 20 करते हैं. A and B are 2 points which are 100 meters apart on the same horizontal plane. Kind of a similar question. So there's a point A, there's a point B, 10 meters apart. So initially they have a distance of 10 meters. Okay. Particle P starts to move from rest at A directly towards B. Okay, so this is particle P. It moves in this direction towards B with a constant acceleration of 0.5 meters per second. So per second square. So acceleration is this. Another particle Q is moving directly towards A. So now it's moving in the opposite direction. So Q is moving here with a constant speed. Its speed is constant. So U and V, they're both the same, which is 0.75 meters per second. So in this one, acceleration is 0 since the speed is constant. And for this one, you don't use the equations of motion. That would be a waste of time. You use the O-levels formula. Speed is equals to distance over time. But now we call it distance is S, speed is V. V is equals to S by T. So S is equals to VT. So use that instead of equations of motion. This is basically speed is equals to distance over time when the speed is constant. Okay. So Q is moving directly towards A with constant speed 0.75 and passes through B at the instant that P starts to move. Okay. So when P passes through A, Q passes through B. At time T, after this instant, particles P and Q collide, find the value of T. So you have to find when the two particles collide. Okay, so when they collide, they, let's say P is here and Q is here. So that means the distance covered by P and the distance covered by Q should be equals to this 10. So the equation you form now is going to be SP plus SQ should be equals to 10. That is when the gap is 0. When the distance sum is going to be 10. Okay. Let's form an equation for SP and SQ. Okay. SQ is going to be simple since it's constant uh, speed. So distance covered by Q would be this V times T. Distance covered by Q would be V, which is 0.75 T. Okay. What about distance covered by P? So for P, it says P moves from rest. So we know that U is equals to 0 as well. So SP is going to be UT plus half AT square. So SP is, I believe, 1/4 T square. Let me check. Yes. Now let's add them up. 1/4 T square plus 0.75 is 3/4. 3/4 of T. This is 3/4 equals 10. Okay, send 4 to the other side, it becomes 40. Bring it to the same side, it becomes minus 10. Solve this quadratic equation, tell me what we get.
T comes out as 5 and minus 8, so T will be 5.
Yes. T equals 5 or T equals minus 8. You should use and completely show either middle term breaking, that is factorization, or the quadratic formula. So T is 5 right before they collide. And then they're asking for the speed of P immediately before the collision. Okay, so that is going to be, we know that U is 0. Let me do the working here. U is 0. A is 0.5. And we now know T is 5. So V is going to be U plus AT. So that's going to be 0 plus 0.5 times 5. That's going to be 2.5 meters per second. Okay, question 21. Last question of this worksheet. Okay. A cyclist starts from rest at point A and moves in a straight line with acceleration 0.5 meters per second square for a distance of 36 meters. Okay, let me draw this. Cyclist starts from rest at point A. Point A hai. Starts from rest means u is equals to 0. Moves in a straight line with acceleration 0.5 meters per second square for a distance of 36. And distance is 36. This is what we know. Let me write distance over here. Okay, so that's the first part of the journey. So we know a lot in for the first part of the journey. U pata hai, A pata hai, S pata hai. So you should be able to find T if needed, and you should be able to find V if needed. Okay. For a distance of 36 meters, the cyclist then travels at a constant speed for 25 seconds. Okay, now its speed becomes constant. For T is equals to 25 seconds. Okay. अगर जरूरत पड़ी तो you should be able to find this constant speed. यहाँ पे और यहाँ पे same speed है और वो इसका V जो होगा ना वो आएगा. So whatever is the V of the first part of the journey, that's going to be the speed here, and that's also going to be the speed here. And for this part of the journey, you're going to use speed is equals to distance over time, not the equations of motion. Because when acceleration is 0, then you'll be wasting your time applying equations of motion. Just apply O-levels formula, speed is equals to distance over time, which is now V is equals to ST. No, S is equals to VT, my bad. Okay, so I'm writing it down here as a reminder. So since acceleration is 0, constant speed, so you can use S is equals to VT. Now S is the distance. V is the velocity or the speed. Okay, so that's what we know about the second part of the journey. Okay, so moving on. Before slowing down with constant deceleration, coming to rest at point B. For the third part of the journey, comes to rest eventually at point B. So at point B, V is 0. Constant deceleration, again, there's some deceleration here, which is constant. We don't know the value. And the distance AB, the total distance from here to here is given as 210 meters. This is 210 meters. Okay. Find the total time that the cyclist takes to travel from A to B. Okay, so we know the time here. ये तो 25 है. First part of the journey ka we can find the time easily because we already have 3 parameters. So U is 0, A is 0.5, S is 35. We need T, so we can do S is equals to UT plus half AT square. 36 equals 0T plus half 0.5 T square. So T is 36 into 2 divided by 0.5 and then square root of that, which gives us should be 12 according to the answers. 36 into 2 divided by 0.5. Yes, it is 12. So time comes out to be 12 seconds for the first part of the journey. So now I'm writing T is equals to 12 here because we know that too. Okay, for the second part of the journey, time is 25, so we already know that. But for the third part of the journey, we don't know the time. टाइम भी नहीं पता, बस एक ही चीज पता है, फाइनल स्पीड 0, और कुछ नहीं पता. सो बाकी चीजें पता करनी है इसकी. इसकी एक तो इनिशियल स्पीड पता कर सकते हैं. वी कैन फाइंड दिस आउट because it's the same as this. So let's use the first part of the journey to find V as well, that we can use as U for the last part of the journey. Okay, so now V is going to be, I can use V is equals to U plus 80 because I have everything now. So I can use more than one equations of motion. So V is equals to U plus 80 is fine. V is equals to 0 plus 0.5 times 12. So V comes out to be 6 meters per second. So this is 6, which makes this 6. So for the second part of the journey, we know that U is 6. I mean the third part of the journey, U is 6. So now we know U, which is 6. We know the V for the last part of the journey, which is 0, but still time nahi pata, so distance bhi nahi pata, और deceleration या acceleration भी नहीं पता. अब distance हम निकाल सकते हैं. How can we find the distance of the last stage of the journey? We know the distance of the entire journey from A to B is 210 as given in the question. And also we know the distance of the first part of the journey, which is 36 meters. That's also given in the question. We can find this distance from the formula and then add the first and the second distance and subtract it from 210 to get the distance of the third part of the journey. Okay, so the distance of the second part of the journey is S equals V aa gaya 6, T aa gaya 25. So this becomes 6 into 25 is 150. 150 meters. So distance of the last part of the journey should be last part would be total distance is 210, subtract the middle distance, which is 150, subtract the distance 36. So 210 minus 150 minus 36 is 24. So the distance of the last part is 24 meters. So this comes out to be 24. करना क्या था, मुझे तो वही भूल गया क्या कर रहे थे. Find the total time. Okay, so now you should be able to find the time for the last part of the journey. So the time for the last part of the journey would be you know U, which is 6, you know S, which is 24, you know V, which is 0. So we need time here. So V is equals to U plus 80. No, V square is equals to U square plus 2S. Not even that. S is equals to half U plus V times T. Yes, this should give the time. So S is 24 equals half 6 plus 0 times T. 8 are there. So time for the last part of the journey is 8. Let me enter that in the figure as well. Time here is going to be 8. Let me send you guys a new link. So total time is going to be 12 seconds for the first part, 25 seconds for the second part, 8 seconds for the last part. So sum of these three should be the answer of part. So the total time should be Uh, 12 plus 25 plus 8. 45 seconds. Okay, part 1 is done. Part 2. Alright, what's part 2? Part 2 says, um, 24 seconds after the cyclist leaves point a car starts from rest from point A with a constant acceleration of 4. Okay, now there's a car that leaves point A. The car has a constant acceleration. This is the car. Okay, so 24 seconds after the cyclist leaves point A. So, what was the time we considered here at A when the cyclist left? The time was T. That was the variable we took throughout the first part. So, now when the car leaves, the time is not, we can't use the same T because that was for the first part. But now the time is 24 seconds later. So every time you use time here, you're going to use t minus 24 because t is the time for this part. And for the second part, it says that the car leaves 24 seconds later. So you have to use t minus 24 every time you will need to use t. You will not use just t, you will use t minus 24 for the car every time. Since it says that 24 seconds after the cyclist leaves A, the car starts to move from rest. Also, it says it moves from rest, so U is going to be 0. So we know U is 0. We know the expression for time, which is t minus 24, not just simply t. And it says that the acceleration is constant, which is 4. So A is 4. So, firstly, the cyclist left A, and 24 seconds later, the car leaves A. Okay. It is given that the car overtakes the cyclist while the cyclist is moving with a constant speed. So when the cyclist is in this region, when it's moving in the with a constant speed, the car finally overtakes it. Even though the car started to move 24 seconds later, but since the cyclist is slow and the car is moving with a constant acceleration, so that means its speed is increasing. So eventually it catches up with the cyclist and overtakes it. And you're told that that happens in the yellow region when the speed of the cyclist is constant. Okay. It is given that the car overtakes the cyclist when the cyclist is moving with a constant speed. Find the time that the car that it takes from when the cyclist starts until the car overtakes her. Okay, so you have to find the time when the car overtakes the cyclist. Okay, so when the overtaking happens, the distance covered by both should be the same. There was a car sorry, there was a cyclist moving initially, let's say it was somewhere over here, and then 24 seconds later, the car starts move and eventually catches up with it. So the distance covered by the cyclist, this is the cyclist, and the distance covered by the car, this is cycle, and this is car. It must be equal when they overlap. So at overtaking, distance covered by the car should be equals to the distance covered by the cyclist. A cyclist What is the distance covered by the cyclist? We know the U, we know the A, and we know the expression for T. So we can find the expression for S from here. S of the cyclist, sorry, not the cyclist, the car. For car, S could be UT plus half AT square, UT plus half AT square. So U is 0, T is T minus 24, plus half, A is 4, and T is T minus 24 squared. So the distance covered by the car is going to be half and 4 gets cancelled, 2 times T minus 24 whole square. Okay, so I'm going to use that here. 2 times T minus 24 whole squared. That's the distance covered by the car when it, at this point, it overtakes the cyclist. Okay, how much distance has the cyclist covered by now? So let's go back to the original graph, I mean, the original figure. So the cyclist covers this much distance. In the red part, it covers a distance of 36. And then it moves into the second part of the journey. And let's say the overtaking happens somewhere over here. So we have to find the total distance starting from A. The distance would be 36 plus some extra distance. So distance covered by the cyclist is going to be distance covered by the cyclist is going to be first initial 36 kilometers and then some distance in this part. Let's call it distance cyclist constant speed. So let's say distance constant. Distance inside the constant speed. So plus distance in the constant speed region. By this, I mean distance in the yellow region. 36 plus distance in the yellow region. So the distance in the yellow region would be, let's use the formula. What do we know? We know that the speed now, what was the speed here? It was 6. So the speed is 6. U is 6 in the constant region. So constant speed region. We know U is 6. And time is not going to be T. It's now going to be the time within this part. So it's going to be some time minus this is 12. So it's going to be T minus 12 for the yellow part. Time will be not T because T तो शुरू से शुरू हो रहा है. पहले इस पार्ट के 12 सेकेंड्स हुए हैं और इस पार्ट के 12 से आगे सेकेंड्स हो गए. सो लेट्स से अगर 14 सेकेंड्स पे वो मीट कर रहा है इधर तो फिर यहाँ 2 सेकेंड्स गुजरे हैं तो आपने वो 2 सेकेंड्स यूज करना है. सो वी नीड T minus 12. So time is going to be T minus 12 in the yellow region. Okay. And we need S. So we can use, we also know acceleration and this part is 0. So we can use just S is equals to Vt since acceleration is constant. So S in the constant speed region, S in constant speed region is V, which is 6, and T, which is T minus 12. So distance covered by the cyclist is going to be 36 plus the distance covered in the constant speed region, which is this. So now you enter this here. So equate it to 36 plus 6 times T minus 12. Okay. Please form a quadratic equation over here and tell me what you get. Expand the left-hand side of the equation, expand the right side of the equation, tell me what quadratic equation do you get by expanding this, both the sides. Are you forming the equation? I'm going to write what it is supposed to be. So when you simplify it, expand it, move the values around, you should get t square minus 51t plus 594. Okay. And then when you solve this equals to 0, you get t is equals to 33 and t is equals to 18. Okay. One of these is an acceptable time, the other one is not. So which one is acceptable? Let's see. Okay. It can't be 18 because we have used t minus 24 in the question. So if you use t is equals to 18, then it becomes 18 minus 24, which is senseless. That doesn't make sense. So the time has to be 33. So at the 33rd second, the car overtakes the cyclist. The last three questions were pretty challenging, especially the last one. So I did go over it. You might have not completely understood it. I hope you've taken proper notes of it. और आज का homework ये है कि you're going to redo the last three questions again. ठीक है? Whenever you encounter a question that you find really hard, and you will encounter such questions every now and then, because the paper is supposed to have easy questions and intermediate questions and then really hard questions. So this is one of those questions. So please always redo that questions on your own, preferably within 24 hours of the lesson. वरना उसके बाद करोगे तो वो आधे से ज्यादा चीजें भूल चुकी होती. So the mechanics homework for today is redo the last three questions again. All right, I'm going to stop recording this and we're going to discuss the paper.